All right. So like I said, this is an interesting studio mainly because everybody will have a different outcome, and you can add your own personal touch to the message that you want to scroll on the 4/7 segment displays. So an individual assignment, it is supposed to be done without much help from the TA, and this is mainly because all the components that are in this, they are either provided to you in the write-up or you have already looked at in a studio before this. So it's an accumulation of all those learnings. The phrase that you choose to display has to be unique to you. So this cannot be something that is very trivial, like displaying 10 identical characters. That's not going to count. The number of characters, the minimum limit is 10, the maximum limit is of course 16, because we have a 4-bit counter that's part of this design. So any message that is between 10 and 16 characters, if you choose your message that you can use the A through F characters, then it'll be really good. Otherwise, you'll have to come up with a more creative way to display the message that you want to. But it has to be an individual phrase, more than 10 characters long. Any questions about the studio rules? All right. So the main resource for this is the block diagram, and the one that I'm showing you right now is not of a very high quality. High quality PDF is attached on Piazza that I highly recommend you using, because then you can zoom in and clearly look at the signal names, the inputs and outputs. You can view all of that very clearly in that diagram. So I would recommend you to download that quickly if you can. Now, there's a particular color scheme that I've used in the scrolling display block diagram. Black is for inputs and outputs of the top level. So the solid bold line that you see, the big box, that's your top level design. So all the signals that are coming in on the left and they are going out on the right, those are your inputs and outputs to the top level design, and the color black is chosen for that. Red is for names of the inputs and outputs that are local to the component. So inside the components, for example, over here, the clock divider, clock and message clock, that is in red because those are local to that particular component, clock divider. Blue is being used for component names. So for example, as you can see, you have clock divider, 4-bit counter, 4 display drivers, and an LED display. So in total, you have 1, 2, 3, 4, 5, 6, 7 components, and all 7 are unique in this case. This is slightly different from the previous studios that you have done, where display driver 1 and display driver 2 were the same component but instantiated twice. So these are 4 unique display drivers, and those are 4 because you have 4 7-segment displays to control. And then the LED display component is essentially managing the anodes and the segments, right? So for example, if you have 4 signals coming into the LED display based on the clock, actually, there should be an additional wire here, which for some reason I have not drawn. The clock should be from, I'm sketching another wire here. That should be it. So the output of the clock divider needs to clock the LED display. So essentially what we are saying is, let us finish this first. So blue is for component names. Pink color is used to represent a multi-bit bus. So for example, if you see /4 or /7, that's a 7-bit bus and a 4-bit bus respectively. And then green is used to define some intermediate signals that need declaration in the top level design. So a lot of these things you guys have already done, which is why uh, I've made this sort of an individual assignment without much help. And you have 2 weeks to figure this out. So I think that will be good. So let's briefly talk about what each of the components is supposed to do. The first source, the first component is clock divider. And the purpose of this is to take in the 450 megahertz clock, so a very high speed clock, and then slow it down to about 1 second so that I can use this as the timing for the scroll to happen. So if I make this 450 megahertz, then it, no matter what message you display, it will appear as if everything is on all the time. You don't want that to happen. You want the scrolling on the 7-segment displays to happen slowly so that you can actually view the message being scrolled. So slow it down to 1 second. And the idea to bring down the clock from 450 megahertz to about 1 hertz is to use a very big counter. So to explain this, I will quickly draw up a counter counting sequence, right? So a general counter, if you see, if you have a, say, a 4-bit counter, how is that going to count? Well, it's going to do that and 1 and 2, so 0, 1, 0, 1, 0, 1, and so on. 2 zeros, 2 ones, 2 zeros, and 2 ones, and so on. 4 zeros, 4 ones, and so on. 8 zeros and 8 ones, and so on. So if I increment this counter at the rate of 450 megahertz, you can clearly see as I move up in significance from this to this to this, my frequency keeps getting divided by 2. So if I make a very, very long counter, I think I suggested 26-bit counter. So instead of 4-bit counter, if I make a 26-bit counter, the most significant bit over here will be the slowest, right? So it'll change at a very, very slow rate, and your goal is to bring it down from 450 down to about 1 second, right? So that's how we are doing this, by making a very, very long counter. And the output is being called message clock. Some of the code is given to you. For example, it's a procedural code. And if there is a clock tick event and the clock is 1, meaning that we are observing the positive edge of the clock, as soon as that happens, you are incrementing the count by 1. Count is a signal that you need to declare soon after you write architecture and before you say begin. And you're defining that as a 26-bit vector. So that needs to be done. And also, after you end this process, you are going to assign the 24th bit of the signal count to the output message clock. So you're going to need to figure that out. How do I take the 24th bit, and if you want even slower, 25th bit of the signal count, and assign that to message clock? This is supposed to be done using the signal operator, the signal assignment operator that you have used in behavioral codes. So that's step number 1. And I highly recommend that after you design this particular component, clock divider, you attach the input clock to the onboard clock, attach the message clock to an LED of your choice, say LD0, and then try to synthesize your design, implement your design, generate the bit stream, download it on the FPGA. And as soon as you do that, as soon as you program your FPGA, because clock is a input signal that is coming from a crystal oscillator that is on board, it is going to be active the entire time. So you don't have to switch anything. You don't have to turn on anything. You just program the board, and the LD0 should blink at about 1 second, right? So as soon as you design, I highly recommend you test that particular component out. Also read through this regarding the libraries that you need to add to your VHDL code at the beginning, if they are not already present. So that's the clock divider, right? So slow down the onboard clock. So that's step number 1, using the clock divider. The next step is to design a 4-bit counter, for which you are already given a lot of the code. So the code of the counter is already given. You are going to have to look at it, understand it, and if there are any things that you need to adjust, so for example, if there are any syntax errors, you need to keep track of the signal names that are being used for input, output, or for intermediate signals, and make sure that this counter is being triggered by the slow clock now, the message clock, and it's going to count from 0000. That's what we are defining at the beginning. Initial state is all zeros, and it'll go all the way to 1111 and circle back to all zeros. Ideally, I would want you guys to connect the enable, clear, initial value, and all these control things to maybe some switches. So if you connect the control inputs of the counter, enable, load, initial value, and clear, instead of connecting them to something that is fixed, in other words, hardwiring them, if you can connect them to switches, so for example, for this, you would need 1, 2, 3, 4, 5, 6, 7 switches, then you get more control over how your message scrolls. So for example, if you wanted to pause it at any time, you could pause it using the enable disable. If you wanted to load an initial value, so for example, if you wanted to start off your message to scroll from the 5th character at some times, you can use load an initial value for that. And then if you want to arbitrarily choose a time at which you want to clear the outputs, essentially to make the counter start from the 1st character, you can do that as well. So I would recommend you, so in the first iteration, this is fine. You can connect that to some hardwired ones and zeros. But in your final design, I highly recommend that you connect them to switches so that you have a more complete, a more generic 4-bit counter. Next, the counter is going to output a 4-bit sequence, right? So it may be 0000, or it may be 0001, and so on, all the way down to 16, and then it'll, all the way down to 15, and then you'll come back to 0. As you can clearly see, that increment is happening at the rate of the slow clock, about 1 hertz. Using the display driver and the when statements, when the counter outputs all zeros, you are going to display your characters here, X, Y, Z, and A. Some different characters, right? I'm just using X, Y, Z, and A to say that when the counter is at 0000, you have 4 different characters being displayed that control the 4 7-segment displays. And then eventually they go to the LED display that takes care of the multiplexing between those characters, and then eventually displays that on the 7-segment displays, all 4 of them. Now another crucial piece of this, the 4-bit counter is given. Another crucial piece of this is this guy. Like, how do you write the 4 unique display drivers? These are not the same component instantiated 4 times. This is actually 4 different entity names, 4 different components. And they're different because they output a different character when the sequence is 0000. So for example, when the counter output is 0000, the least significant 7-segment display displays an E, and nothing here, nothing here, nothing here, right? And then when it is 0001, you have C there, E there, nothing here, nothing here, and then so on, right? As it scrolls from left to right. Now you can figure out a different way of doing this. That's completely up to you. But this is one very straightforward way to scroll a message that I'm recommending here. And then source 7 is, of course, the LED display that switches between the 4 7-segment displays. The idea that instead of using 28 signals, I use 7 of them, and then I use the anodes to switch between the segments. Something that you guys have already seen before. And then, so LED display is given to you. Display drivers are actually given to you, but you have to modify the code for your message for this. And then top level design, you have to write from scratch. So I would assume that most of your time goes in adjusting the 4 7-segment 4 display drivers, and writing the top level code. Now going back to one of the components, counter 4-bit, as we tested the clock divider, I would also recommend you to test the counter 4-bit. So have just these two components, just these two. Come on. Make a top level version 1, and top level version 1, connect the clock divider to clock, connect all these guys to switches, and output them to 4 LEDs. And as the clock goes, you should see the LEDs blink, counting things in binary at a slow speed, right? At about 1 hertz. So that way you test the counter 4-bit as well. And then display driver and LED display can be tested all at once. All right, so that's what you have over here. That's essentially your lab. And in terms of deliverables, you have all the VHDL code and the XDC file to be submitted on Gradescope. That's due next Monday. And in your write-up, make sure that you mention the phrase that you used, more than 10 characters long. Now, if you get done with this very quickly, as extra credit, you can go for a message that is beyond 16 characters, say 20 characters or 25 characters. It's up to you. Above 16 characters, figure that out, like completely on your own. You will need a lot of these things that you've done in this one, but that is extra credit. Also due Monday of next week. All right, so that's what I'm going to say in terms of our discussion.